Hello everybody, my name is Chris, and today I've got an interesting repair for you that I think you'll really enjoy. This Vacheron and Constantin pocket watch will get a new balance staff. Now before you say, "But Chris, I've seen you replace staffs before." Well, I eventually learned that sometimes replacement staffs just aren't available, so this time I had to literally make my own, and you'll get to see that process as filmed by the microscope. Now, most of this narration is really after the fact, so as I was filming this, I really didn't know what was in store for me until much later. Honestly, the watch was running, but not badly enough to suspect a bad balance, and I thought this would end up being a really simple service. In fact, I questioned whether I even wanted to film this one. As I learned from past videos, basic services that don't feature new or interesting repairs tended to perform rather poorly on YouTube. But I decided to keep the camera rolling because it's the first Vacheron I've ever done, and I figured you all might enjoy at least watching me do a full workup on it, considering it's an early timepiece by one of the most recognized luxury brands in modern times. A viewer named Anthony sent me this one. He's a collector of pocket watches, and he too appreciates the beautiful designs that are easily found in timepieces of this era. The pride and workmanship is really evidenced by the attention to detail, which is not something we can easily find in devices of today's disposable society. With the main complaint that it starts and stops somewhat randomly, Anthony hopes I can get it into good working order so that he can pass it on to his children and grandchildren. A little bit of rust there, but that'll be easily dealt with later. I've said this many times, but this is my favorite stud carrier design. It allows me to easily separate the hairspring from the balance cock while it's still installed on the plate. You see how it just kind of slides right out to the side? Now I can just remove the balance cock separately from the balance. This way it doesn't take the balance with it while it dangles from the hairspring. The cap jewel, or end stone, is separated from its respective hole jewel for cleaning. Ooh, well that's the problem right there. Looks like something's going on with that lower pivot. With the roller removed, yes, it looks quite worn and quite a bit bent over. This would be the primary cause for the erratic timekeeping seen earlier and may explain the stopping and starting. As many of you know, these pivots cannot be straightened out without them breaking off completely. Originally founded in 1755 in Geneva, Switzerland by Jean-Marc Vacheron, the business is one of the oldest watch manufacturers in the world. There were several reorganizations throughout its history. In order to scale the business by starting exports to France and Italy, the company brought in Francois Constantin in 1819, and the company then became known as Vacheron and Constantin. I'm just letting down the remaining power of the mainspring. Anyway, Vacheron and Constantin eventually hired Georges Auguste Lachot as technical director who supervised manufacturing operations. A fun fact about Lachot is that he was the first person to develop and use pantographs for standardizing production, starting in 1841. This innovation allowed him to perfect the consistent and accurate manufacturing of identical movement plates and components in series production. In 1970, the company officially changed its name to Vacheron Constantin, changed hands a couple times, and eventually landed within the Swiss Richemont Group since 1996. They continue to produce around 20,000 timepieces per year and are most recently recognized for developing the most complicated watch ever produced, the reference 57260, with a whopping 57 complications, 242 jewels, and over 2,800 components. Yikes, I'd hate to be the Vacheron technician who draws the short straw when that thing comes in for a service. Even the keyless work of this Vacheron is elegantly designed. For example, check out that rounded polished edge of the yoke. They certainly didn't need to do that. The pallet bridge is being removed, and also another beautifully designed component. I'll also separate its end stone for a more thorough cleaning. Gosh, I have to admit, even with some hairy mud stuck to it, this pallet fork's a real stunner. I appreciate the extra effort I'm sure it took to make a separate cock for the escape wheel, rather than putting it under the same bridge as the rest of the train. Anyone working on watches knows how tricky it can be to seat the pivots of an escape wheel with a cap jewel. As with the others, I'm also separating this cap jewel for cleaning. This is the train bridge, which doesn't look too bad. The jewels have some dried up gummy oil inside, but no damage whatsoever. The crown wheel comes off in its own bridge. I love this wolf tooth design of the crown and the ratchet wheels on these older Vacherons. The ratchet wheel is shrouded by this decorative plate, perhaps to protect it from debris or maybe just for aesthetic reasons. Do you see this integrated click on the edge of the plate? Well, that's a common trait shared among various Swiss pocket watch calibers of this era. Since the center wheel sits between the barrel and the ratchet wheel, this needs to be removed before the train can be uninstalled. Inspecting the wheels under the microscope, I'm seeing the usual amount of dust and fibers mixed with the dried oils. Pretty common to see in pocket watches this old, which is why you should really get them serviced. Trying to run them in this state over an extended period of time will cause the debris to wear into the steel of the pivots and pinion leaves, kind of like an abrasive slurry. The stem, along with the sliding clutch and winding pinion, are secured into the movement. Finally, the lower end stones for the balance, the pallet, and the escape wheel are removed for cleaning. You can try to run the parts through the cleaner with them still attached, but if you were to look at them afterwards, you'll see the debris and gunk still trapped between them and their hole jewels. As always, a little scrubbing with a pegwood stick goes a long way. The old oils and debris have been caked on for decades, and I found the parts have a better chance coming out clean on the first try with this extra step. I suppose there's a special tool for this to remove that crown wheel seat, but the tweezers seem to work okay. The ratchet wheel is another tricky one to remove, but very similar to the approach I took with the crown wheel. In this particular design, the hooked part of the barrel is actually removable. Since using the same method as the crown wheel, I can use my tweezers to unscrew it. Evidently, the barrel arbor is not part of the barrel at all. It's integrated with the ratchet wheel. So this mainspring is pretty tired, and I was able to find a white alloy equivalent. So now all you gotta do is just press it in. Oh, you gotta be kidding me. It is just a hair too wide. I'm gonna have to wind it in myself. All right, well, nothing's ever easy. Pretty much par for the course for this watch. Well, to give you a comparison of a tired pocket watch mainspring and a fresh one, look how this fresh one just coils way out, all the way out here. That's gonna be plenty strong and light years ahead of what was in there before. Nice. Oh, and the most satisfying sound. Click. Love it. They say these are pre-lubricated from the factory, but I don't think a little bit of HP, at least the amount that I added, hurts anything. Okay, so we have the ratchet wheel, and there's a tiny bit of oil. Well, again, HP 1300, right where it would fit within the barrel, like so. And then the arbor we put a little bit of HP 1300 on the top of the arbor. Now the interesting thing about this lid is it was provisioned to have a Geneva stopwork. And for those of you who have worked on older, say late 1800s, early 1900s Swiss watches, you will notice that they sometimes have what looks like a little star mechanism here with a finger that protrudes into it. And so basically what that does is it isolates the barrel into winding along the most consistent part of the power curve, eliminating the first turn and or the last turn where power delivery is not as consistent as the rest of the range. This barrel lid was provisioned for it. This watch didn't have it installed. I've seen this before. I don't think it's actually just missing. I think they just didn't put this on it. And we've got a white alloy mainspring in here now, so it's going to be fairly consistent. I'm not too concerned about it. The jewels are in great shape, and I'm just verifying using the microscope that there's no other debris stuck within them. Aside from the plating being a bit worn, everything looks good. The automatic oiler is used to deposit some Mobius 9010 on the balance and escape wheel jewels. The pallet jewel is intentionally left dry because there isn't a ton of wear to be expected given the short range of motion experienced by the fork. In case you're wondering, yes, I will get to that staff. However, at this point in the repair, I was still searching all my sources for a replacement that I could purchase. So I figured I'd just proceed now with as much of the reassembly as possible in the meantime. I'm reassembling the balance cock now as well, and it too will receive some 9010 through the hole jewel. This blue grease is Mobius 9504 and is used on the harder metal-to-metal sliding surfaces, like where the sliding clutch ratchets against the winding pinion. The stem is also lightly greased as well before it is fitted and secured to the movement. The click spring is returned to the barrel bridge where it straddles the ratchet wheel. I like to inspect each wheel before they're installed to catch any stray fibers that may have gotten stuck to them after cleaning. With the fourth, third, and second wheels in place, I can lower the barrel down, sliding it in such a way that the center wheel slips underneath the ratchet wheel. A bit of HP 1300 is applied here when installing the crown wheel. The train bridge is refitted to the movement. I'm ensuring the pivots are properly seated before tightening down the screws. The escape wheel pivots are super tiny. I believe these pivots measured between 0.08 and 0.09 millimeters. Makes me ever more thankful that I don't need to try seating them along with the other pivots under one plate. I'm using Mobius 941 to lubricate the faces of the stones to further reduce the friction between them and the teeth of the escape wheel. I only do this under magnification. And that's just to give you an idea of the size of those little stones. With the pallet fork in place, I can manipulate it with slight downward pressure on the bridge until I feel the pivot become seated. HP 1300 is used on the center wheel and 9010 is used on the other bearings. I've also read that 1300 could be used on the third wheel instead, but I usually opt for 9010 if it's jeweled. I'm applying a little HP 1300 around the center wheel arbor before friction fitting the cannon pinion. The cannon pinion is just friction fit over the center wheel. There needs to be enough friction so that the center wheel can turn and drive the motion work with it. However, the pinion also needs to slide freely around the center wheel arbor so that the user can set the time independently of the functioning of the movement. One of the most common issues with antique pocket watches is sometimes that cannon pinion becomes a little too worn and loose, and it'll give the illusion that the watch is losing hours per day, but in reality the cannon pinion just needs to be tightened up a bit. This is the yoke, which drives the sliding clutch back and forth when changing between winding and setting mode. And since this is a lever set watch, this lever is used to change between modes and not by pushing or pulling on the crown. Honestly, there's no service guide I'm referencing, so I'm just using a little intuition to determine where I would apply any grease. For example, this setting lever spring gets some 9504 grease along the edge where it rides against the lever. Same situation as where the yoke makes contact with the lever. The intermediate setting gears also have shouldered screws, which receive some grease as well. Something's not quite right here. If I pull this lever, now I should be in setting mode. So I'd set the setting gear and intermediate gear. But when I release setting mode, the yoke is supposed to pull the sliding clutch back toward the winding pinion and disengage from the setting gear. And that's just not happening. Something is preventing this from moving out to disengage from this. So got to figure out why. And I'm wondering if when I installed the crown wheel plate that it's somehow jammed up with the winding pinion right there and it's kind of jammed inward. So I'm going to try to loosen this up and kind of shimmy it around and see if I can get the teeth to mesh a little cleaner. Probably only need to loosen it. That sounded promising. Let's give that a try. Okay, as you can see, they're meshed a lot nicer now, and I betcha I can give the watch a little bit of a wind. Buttery smooth. So we've got winding mode. You notice how the sliding clutch is slid out so it doesn't engage the setting gear. Alright, so now with setting mode, the yoke slides the clutch out. And now with the sliding clutch out, disengages with the winding pinion, and now we're in setting mode. The pallet fork is cycled through all teeth of the escape wheel to ensure there are no issues with locking and unlocking. The thing about these older Swiss movements is that, unlike their American counterparts, it's very difficult to identify their caliber. And even if you could, finding the specific part like a balance staff for that caliber is hard without the kind of factory records that the Americans had. This Vacheron doesn't even have a caliber marking, so all I have to go on is its size in Lin. Well, despite my best efforts in searching for that balance staff, no one had a staff that matched the specifications of the one I needed to replace. So what started out as a straightforward service and staff job quickly derailed with this major setback. It's not like I can make my own staff. Or can I? Of course, I did try massaging the pivot back to straight, but all that did was break it, as expected. Sometimes re-pivoting is an option, but in this case I couldn't get the staff to run even close to true, which is absolutely critical for this kind of task. And then I noticed the rivet of the original staff had begun to fail. Actually, this ended up being a pleasant surprise, as now I can remove the staff in one piece in order to take the measurements I need to make the new one. Most dimensions are critical. In some cases, we're talking about hundredths of a millimeter. So measure twice and cut once, am I right? Henry Freed has an excellent book, and there's a chapter dedicated to making a balance staff from a steel rod. The size of the rod to choose should be at least the width of the largest dimension, which in this case is the hub. Oh, and feel free to skip to the next chapter of the video if you're not interested in watching me make the staff. In order for a balance to keep time at all, the staff needs to run completely true, as in no wobbles as it's being formed. As much of the creation of the staff as possible needs to be done in one shot. In other words, I can't remove the rod from the lathe once I start. The first thing I'll do is turn the seat for the balance. I want it to be snug and squared off so the wheel sits firmly against what will eventually become the hub. I occasionally check my progress with a micrometer and against the original staff for reference. The book is very clear about ensuring the shoulder is squared off so the balance sits flat and doesn't wobble. As I get closer to the final measurement, I switch to fitting the part onto the work and then make smaller adjustments until I'm happy with it. The width is good, but I need to extend the length a bit, even oversizing it a tad. I now need to turn the section where the hairspring collet needs to friction fit over, and also the undercut needed to rivet the staff to the wheel. The sharp tip of this graver helps undercut that portion that will be riveted to the wheel. Here I'm just double checking the hairspring collet will fit tightly over the next section. I'm now turning the final upper section that will eventually become the upper pivot. Freed indicates some recommended proportions regarding the conical shape relative to the body of the pivot itself. For this delicate operation, I'm using very little pressure from a round-nosed graver. The original staff had a 0.11mm pivot, but I don't have the cojones to try to turn it down that small on the lathe. Instead, I'll shoot for, let's say 0.15, and then I'll burnish it to size on the jacket tool. Well, the upper part of the staff is done for now. The lower half is much more challenging, and I did screw it up on my first attempt, so what you're actually seeing is my second attempt at making this staff. The hub is turned to size and then roughly shaped and extended down to the section that fits the roller table. I had to make my own parting tool for this step. I'm very comfortable using the diamond-shaped graver, but when making the lower end of the staff, I lacked the clearance needed to use it. So this low-profile tool is somewhat new to me and is the reason I screwed up the first attempt. Also, I occasionally take measurements to ensure that I'm not cutting away too much. The roller table needs to friction fit onto this section and sit against the hub. I'm extending it as far back as I can, knowing that a portion of this will become the pivot. Nothing like saving the hardest part for the end. I'm turning a nice long pivot down to 0.15 millimeters that I plan to reduce and shorten on the jacket tool when fitting it into the movement. If you're wondering, that blob of Rodico helps prevent the staff from pinging and rolling off the desk after it's been parted off the rod. Well, that's that. Now to see if it works. The staff is riveted onto the wheel using a dome-faced punch to expand the rivet section of the seat. And now I'm flattening the rivet using a flat-faced stake. It's always good to ensure the staff is riveted securely. I'm using a piece of Rodico to try to move the staff within the balance to make sure it's good. The roller table is reinstalled with the impulse jewel facing the same way as before to keep the wheel as close to poised as possible. Before the first test fit into the movement, I still need to reduce the size of the pivots to 0.11 millimeters. The jacket lathe tool is used along with a pivot file and burnisher to reduce the size of the pivots by small increments. The burnishing process finishes off the surface of the steel by work hardening it in the process. Later, you'll see how I use this tool to shorten the pivots as well. On my Steiner, the number on the runner represents the size of the bearing in which the pivot needs to rotate. As you can hear, the frogs are still quite active this time of year. One edge of the burnisher is a safe rounded edge. This is for working pivots with a conical shoulder, like the ones found on this balance staff. This is just the first step, but I'm starting with the larger runner and will work my way down to smaller slots until I reach the size I need. The tip of the pivot is rough and needs to be finished off by rounding it smooth. For this, I use the lantern end of the runner, which is hidden under the small knurled handle. The pivot extends through the hole corresponding to the 11 marked on the lantern and provides a safe support for me to shape and resize the tip. The finish of this smooth and round tip is critical to achieve good amplitude since it rotates against the jeweled endstone of the bearing. The process is repeated for the other side, but with the width of the lower pivot resized, I can now fit the balance into the movement to determine how much I should shorten it. So I'm now reinstalling the balance without the pallet fork. The reason I'm doing that is because I just want to make sure that the balance wheel has good freedom of movement up, down, left, and right, and I don't want to just whack it against the pallet fork. I also do not yet have the lower end stone setting installed. That is because I don't want to have to tighten down this balance cock and have it snap the bottom pivot because I didn't trim the staff enough. I will inspect to see how far out, if any, the staff is protruding off the other side before I go ahead and reinstall that end stone. No! I hate when that happens. Please don't break a pivot. Ugh. Nobody breathe. So now that's shortened where I want it to be. The last step is to round up the tip of what remains. And then hopefully we can call this done. With the lower end sized and re-rounded, I can fit the balance back into the movement and then safely install the lower end stone. So just a little puff of air. Nice. I guess the very last step is with any balance job, it's good to verify that the balance wheel is still in poise. And the reason why that's important is the poise will actually determine how accurate the watch will run in various vertical positions. If there's a heavy spot on one end of the balance, it'll speed up in certain positions and slow down in other positions by a proportional amount. So we're going to go ahead and verify that. That's more than I'm comfortable with. The heavy spot was on the roller jewel side. So what I'm going to do is I'm going to try to add a timing washer to the opposite side, or one of these screws. If you want to know a little hack for getting those fiddly timing washers onto the timing screw, go ahead and lick the tip of your finger so it's stuck there, and then you can kind of just sort of press into it without, stabbing yourself and getting blood everywhere. And you got a timing washer on your screw, and that's it. I don't know where I learned that. It's not something I came up with on my own. So this is going to be an iterative process, and at a certain point, the addition of timing washers are going to be too coarse grained to get the poise that I need, at which point I'll have to consider removing material off of one of the screws, and if that's the case, I will show you that. So the balance is almost in poise, and there's one little heavy spot right over here. And what I'm going to do is, instead of adding more weight to the opposite side, I'm going to shave down the screw. And the reason why I'm going to do that is I've already added weight to the balance, and adding weight to the balance will actually slow down timekeeping, and I don't want to do that too much. The regulator was in the center when I disassembled the watch, and I figure if I already added weight, my next step is going to be removing weight. So I have the screw, and please don't, if you're going to do something like this, please don't take a file and just shave down the bottoms of the screws. That's kind of the quick and dirty, really dirty way of doing it, but we're better than that, right? So what we're going to do is we're going to use one of these undercutter tools. They're tiny, tiny little files on the top, and you basically just insert the screw and spin it around, and it actually cuts material off the bottom of the screw that you just won't be able to see anyway. So the trick is just finding the one that fits and then spinning away. So I think it's in poise now. It really should just not rock back and forth extremely much. So I should be able to put it at almost any angle and it'll generally coast to a stop. This is really my favorite style of stud carrier. Just kind of slips right in there, just like that. And just gotta make sure the hairspring is in between the regulator pins. And then the stud carrier screws can be tightened down. So notice I did this without the pallet fork in. And the reason I did that is we'll let the balance come to a rest and we'll check to see how the impulse jewel is aligned relative to the jewels of the pallet fork, and that'll give us an indication how far in or out of beat we actually are. Again, just as an approximation, we might have to dial it in a little bit more once the watch is running and we have it on the time grapher. Recall the impulse jewel is positioned orthogonally to the balance arm, so here the balance is rotated a bit too far counterclockwise, since the jewel should have direct line of sight to the pallet bearings. So now I'm rotating the hairspring collet in the opposite direction of the adjustment needed for the wheel. Now the wheel sits squarely facing the pallet bearing, and this will be a good starting point for the beat error adjustment. Okay, the moment of truth. If you methodically took all the steps and iteratively checked the work along the way, you should never be surprised when it actually does spring to life. I mean, you don't feel any less joy, but it's not really surprising when it comes to life. The true excitement comes when you put it on the machine and you see it perform the way you want it to perform. This is one of those balance cocks with the really tight pins, so I need to put a little effort into getting this guy down here. The last thing you want to do is push it awkwardly and crush your balance pivot. So, what you can do in these circumstances is you can put your cock screw in, tighten it down, not wanting to seat nicely. I'll keep tightening it. This is so nerve-wracking. Come on. How are we doing? Oh, okay. There you are. See, in my other videos, you see me just basically drop the balance into place and the thing just starts running, but it doesn't always happen, folks. Sometimes you get one of these and you're sweating bullets, hoping you don't crush a pivot. Almost forgot about this guy. Okay, so the amplitude is pretty good, very good, almost too good. I don't think I'd want it much higher than that because once you get to pretty close to 360 degrees, you have a risk of it overbanking, which is basically when the impulse jewel swings around all the way and hits the pallet fork on the other side. So I think this is pretty much as high as I want to go, so it's super healthy. The beat error, anything under 1 millisecond for a fixed stud carrier is pretty good. I took a guess at the 52 degree lift angle. It's probably around there in the ballpark. Running a little bit slow at -7 seconds per day, but we can adjust that. There's a little screw on the edge of the balance that moves the regulator. So I'm going to turn it a little bit to the fast, and it'll take a couple seconds for the time grapher to pick up on the reading. So I'd say that's pretty good. Yeah, right about 0. The other test is how it performs across positions. So vertical positions usually perform a little bit worse. This doesn't seem too bad. The rust on the stem is just some surface corrosion. I'm going to try removing it with a small wire wheel in the Dremel while the stem itself is mounted in the lathe. Much better. Anthony would like a light polish to this 14 karat gold case. It's beautifully engraved, so I plan to use a light touch and just shine it up a bit. The inner surfaces of the dust cover and the case back are manually polished by hand. Even with a very light polish, this improved the appearance of the case, and I didn't erase any of the deeper scratches, which I feel are part of the historical record of this beautiful timepiece. When I first started this hobby several years ago, even replacing a balance staff felt like an insurmountable challenge, let alone making one from scratch. Back then, I thought that was something only the mystical watchmaking monks in Switzerland, armed with their magical carbide fingernails and infinite patience, could achieve. I'm thrilled about this outcome, that Anthony now has a reliable timekeeper, and that I decided to actually film this repair without knowing what to expect. As we reach the end of this video, I just want to share my appreciation to my audience who's followed me from the start. You stuck with me during my pre-narration silent film days, and then dealt with my questionable choices of music. But then you also encouraged me to keep narrating when I decided to give that a try. These days, there are tons of watchmaking channels to choose from, and I'm really grateful you decided to visit mine. I try to stand out by diving into some of the more technical repairs, even if my technique isn't always perfect. My goal is to keep things interesting and engaging so that you'll want to come back for more. If you find these videos educational or even entertaining, please consider hitting the subscribe button to get notified of future videos. Also, drop me a comment below to let me know what you'd like to see me work on next. I'd love to hear your suggestions. So I hope you all learned something from this video today, but if not, I hope you at least enjoyed it. Thanks for fixing watches with me today, and I'll see you in the next one.